On the 24th of April 1990, Space Shuttle Discovery launched the Hubble telescope into orbit. This was an exciting time for space exploration, as Hubble promises to produce mind-boggling images to show an early view into our universe. After 30 years, Hubble has done exactly that. Throughout its lifetime, Hubble has taken more than 1 million pictures. Despite becoming the most famous telescope in the world, it is easy to forget that it almost was a complete failure. Soon after it was launched, scientists and engineers discovered a small defect in Hubble's mirror, which made an extremely blurry pictures. The 2.5 meter mirror, which is 8 feet in diameter, is the heart of the Hubble telescope that needs to be shaped perfectly in order for it to produce the highest quality of images. Now, 31 years later, and the cost of $10 billion, and involved thousands of scientists all around the world. This is the James Webb Telescope. It's the successor to the Hubble telescope, but it's 100 times more powerful. I was fortunate enough to have a friend of mine to participate in the James Webb build. He's an engineer and a fellow R2-D2 builder and Wally builder. His name is Matt Hobbs. He agreed to do an interview with my students in Japan. My students are really eager to learn a lot about engineering, and they were happy enough to get a chance to talk to Matt Hobbs to learn more about the James Webb Telescope. This is how it goes.
Hey, Richard.
Hey, how's it going, Matt?
Good. How are you?
Good. How's it going over there? How's the weather going over there now?
Oh man, it's in the high, I guess 60s today, maybe 70s.
Yeah, I just talked to my mother, and she said they're expecting a snowstorm by midnight in Boston.
Yeah, my mom's, they were going to get one in Alabama too. And David was saying Virginia was going to get some more snow too. So, looks like they're going to get a lot of stuff. Not here though.
Lucky you.
I know, right? How's things over there?
Good. Weather's just cold, but it's pretty cloudy, clear cloudy, but it's about 50 to 40 degree weather here.
That's not bad.
Yeah.
Fahrenheit?
Yeah. Well, Celsius, so Fahrenheit would be about 50, 40. Celsius is about 20s, in the 20s. So let me introduce you to my students. These are my prime students here, and they're going to have ask you a couple of questions. You can introduce yourself. Tell them what's your name.
My name is Koa.
Speak louder.
My name is Koa.
His name is Koa.
Koa?
Yep.
Hey, nice to meet you, Koa.
And
My name is Yuna.
Yuna.
Yuna?
Yep.
Nice to meet you.
And
My name is Kaima. Nice to meet you.
Kaimu.
Kaimu.
Yep.
Hey, nice to meet you guys.
All right. And this is Matt. His name is Matt. Okay. Now, when you guys ask questions, I want you guys to speak louder because it's going to be kind of hard for them to hear you. All right. So, who wants to go first with questions? Who's first? And I want to thank you for your time. Appreciate it.
Yeah, no problem at all. One of those things that we enjoy talking about for sure.
That's good. Who wants to go first? Okay. All right. Kaima's going to go first. Go ahead.
How does the satellite open up in space?
How does a satellite open up in space?
Okay, so the first couple of moves, so once it was launched from Earth and then it was on the top of the rocket, it went through a couple of stages and then it separated from the space vehicle. So the first thing that we saw, we actually got to see it on screen and we didn't expect to see it, was that the solar array opened up. And that was all automatic, and that's done by several different motors. It has a release device that is automatically triggered, and then the motors basically pull or push the solar array out. So once that happens, there were a couple other things. There was the antenna that lowered down that's actually can talk back to Earth through the deep space network. And then once that happened, it was all controlled from Earth. So everything after that was done by a command. There was a guy at a computer that would tell it to do something, and then it would go through and do another step, and then we would get feedback from the spacecraft saying, okay, I completed that step, all the sensors look good, and then we would tell it to do something different. Okay. So does that help?
Yeah, thank you.
Okay.
Yeah, no problem.
Una, what's your question?
How many days did it take to build the satellite?
How many days did it take to build a satellite?
Well, if we go back from conception of when we first thought of the idea, it's been around 30 years.
Wow.
30 years. To build satellite or to build this telescope. So the actual production of the telescope was around 15 years.
Okay.
The part that I worked on took around 11 years to build.
Okay. Good question. What's your question?
How do rockets separate in space?
How do rockets actually separate in space?
So that's done by the Space Launch System that they have, so that each rocket is different depending on how deep we want to go into space. Most things only have 2 stages. James Webb had 3 stages. So it launches, and then basically same thing. The computer system is taken over at that point, and the computer says, okay, I've reached a certain altitude. I'm ready to dump the first stage, and it'll actually tell something to release a mechanism, and then that mechanism will fall off. And then right after that, we have to ignite the second stage engine, because if you don't, you will actually get a bump back from that second stage or the first stage, and it will actually knock your rocket out of where it needs to be. We actually had one a couple of years ago actually do that and ended up scrapping the mission. So it's very important that the controls and everything are written correctly, so that once it separates, that second engine fires, and then it'll get to a certain altitude, or it runs out of fuel at a certain time, and then they'll drop that one, and then the third stage will light if it has to have a third stage.
Good question. All right, what's your question?
How far will be able to see?
How far you would be able to see what? The satellite?
How far will we be able to see? So the James Webb is looking, it's actually, so to understand what happens, so light actually comes to us. So, I mean, we're seeing things that have already happened, and then we get the image to our retina, and then it goes back. It's just, we do it really fast. The satellite will be able to see images that were almost 1 billion years ago that it happened. So there will be an image that happened. So there was a star 1 billion years ago. So that star's light is traveling, and it's traveling toward the satellite. And it's taken it almost 1 billion years to get here. But what happens in between that time is that you lose visible light. So all those atoms and protons that were traveling at that time, they start falling off, and you only end up with the infrared images left. So that's where the James Webb comes in. It can actually see and capture those images that have been long ago, and that's why we have to have it as cold as we have to have it, is because we can't see those images unless the mirrors are super cold. So to answer your question, about 1 billion years. We can't even quantify distance because we don't really know or understand that it travels in light speed, but at that time we lose distance and speed because we don't know how fast it's going, where it's been, or when it's going to get to us. So that, I think they'll be able to do some calculations once they get the images back, and we can find out how far out we actually are. So we'll find that out together.
Good question. What's your question?
That,
What's the hardest part of this project?
this entire project was hard. From conception to build, everybody that worked on this thing had to put 100% into what they were doing. The hardest part we had to build, we had to do a couple of repairs, like deep down underneath the membranes. And we had to come up with a way to do that. And to actually do it, we had to get in and hang upside down off of this board to get in and actually do these repairs. So that was the hardest thing I remember having to do. But as far as other people on the engineering side, there were always problems to solve. And these problems had to be solved super quick, as fast as we could do them, because we were already behind schedule, and had to come up with ways to either fix something. We had to come up with a new way to glue something. We had to come up with a special tool to get into a hole that we would have to put a bolt in. So all of those things paid out to be really difficult. But again, I would have to say the entire spacecraft.
Okay. How many robots do you have?
I have 9.
Which one of those?
I've got BB-8, I've got R2, I've got R4, I have a pit droid from Star Wars. My favorite is Wally. I actually have 10 now. Actually, I'm finishing Mo from Wally.
Oh yeah, the little Mo. I'd seen you. I seen that you was doing the little Mo. You got the eyes working now.
Yeah, so I actually burnt the power supply out. Yeah, or it burned itself. I really don't cut it on and it like went up in smoke. So now I've got to pull that back apart and replace that and try to figure out what happened.
Yeah.
I think it was bad.
So you got about 10 robots.
One we're working on is BD-1. Get him going because he was just in Mandalorian. I'm like, okay, I need one of those now. So lots, and BB-9. So a little bit of everything. Mouse droids, scrubber droids.
Yeah. What part of the web did you work on?
So I was responsible for building the sun shields. So it's the big silver part that you see that's shaped like a kite.
Yep. That kite-shaped piece on the bottom. Yeah.
Yep, and it's purple on the bottom, and then it's silver on the top, on the side that's facing the telescope. And to put that into scale, if you've ever been on a tennis court, that's how big it is.
Wow, I didn't even imagine it was that big.
Do what?
I didn't imagine it was that big.
Yeah, it's basically 40 feet by 80 feet.
Okay.
For the bottom sun shield.
So that shield is about the size of a tennis court. How much does it cost? What's the average price it costs to build a rocket?
We can do. We can look and see. So a Falcon 9, for example, which is SpaceX's rocket, is around $57 million.
That's all? Give me 2. $57 billion.
Million.
Oh, million. $57 million. Okay. $57 million.
Kind of put that up against the James Webb. The James Webb cost around $9.6 billion.
$9.6 billion for the Webb. So you put 9, then dot, then a 6, and then a B. How many people are in your project?
Oh, that was anywhere from beginning to end was around 4,000.
4,000 people.
Yeah.
4,000.
And that's all over the world.
Okay. So any other questions?
Why does the web shaped like that?
Why is the web shaped differently from other satellites?
Because it is it's the way it needs to be cooled. So the Mira is the main part of the telescope. So we had to get a large aperture up there. as big as we could get, we had to actually, you've seen that it actually folds sideways. It folds those wings down. So that's so it can fit in the rocket. But we wanted that shape to be as big as possible to be able to fit the biggest rocket that was out there at that time, which was the Ariane 5. And then the sun shields were then shaped to protect those mirrors to actually, so they can never see the sun. And that's why it has that triangular shape. And again, it goes to, you say, well, why didn't we just build a big square instead? But again, it goes to weight. So we want to use the least amount of area to protect that telescope as possible so that the telescope is as light as possible.
Finished our John Webb satellite. So what I want you to do is explain to me what have you learned about it. So what did you learn about it?
Oh, when I'm making it or the interview?
The interview and making it.
In the interview, we know how big was it, and then it was going around the Earth, but very far away. And even it's this small that we made, it took a long time.
Okay, very good. All right. And tell us what have you. I'm sorry. Tell us what have you learned about it.
I learned how big is it
Okay.
and how the satellite moves.
Okay. And what did you learn about making this one?
It was hard.
It was hard. Okay. And Co-op, what have you learned?
I learned how to make and think about the Webb telescope and what you need to make the Webb telescope.
Okay. I have a question for you guys. For the Webb satellite, it uses these dishes all put together. Which shape is this?
And that's like the pen.
Which shape is that? Which shape is this right here? A star, a circle, a square, a triangle?
Hexagon.
Yes. Do you know how many hexagon pieces they used? Shapes that they...
1,000.
No.
200.
200? No.
More.
18. 18 has... Do you know what this material is made out of?
Middle.
Gold.
Real gold?
Real gold. Yeah. So it was real gold layer. So it was hexagon sheet laid in real gold and shaved so that it would be very, very shiny. That's why it's really sensitive. But yeah, real gold. So if we could fly up there with a rocket ship and take it, we can steal this and sell it for real gold. Okay, that's good. So, anyone has anything else to say about it? Yes, yes? Okay, so now, what we're going to do, who's going to keep this? Who's going to keep it? Wait. We're going to do rock, scissors, paper. Rock, scissors, paper. Ready? Go.
Rock, scissors, paper. 1, 2, 3.
Okay, rock, scissors, paper.
Rock, scissors, paper. 1, 2, 3. 1, 2, 3. Yeah.
All right, this is yours. Okay, all right, put it aside. All right, you got to put it aside. And today we're going to work on finishing our circuitry